crossing or cutting of the dimension lines. Alright. Also, the dimension line should not cross any other line of the drawing. Alright. For example, the outline of the drawing itself. Outline of the drawing itself. It should not cut. Alright. So we place the dimensions outside of the drawing. Outside of the drawing. If we have sufficient space inside the drawing, then we can go only for this one. Okay. Otherwise, always try to put the dimension outside the drawing.
Sir?
Okay. Yes.
Sir, but in case the dimension lines cut each other, so what we should do?
I think this is not possible everywhere. Alright. So in that case, suppose we can extend it. Okay. So in that case, what we do? We can extend the same dimension line, these extension lines. Alright. So we can show it something like this over here. Alright. So this is you can say the very rare cases where the dimension lines can cut. Okay. So if it is unavoidable, then we can, in that case, we don't have any option. Alright. In rare cases, that might be possible the dimension lines are cutting. Then in that case, it can be allowed. It can be allowed. Alright. However, in most of the cases, you can see we can provide the dimension lines so that they cannot cross each other. Okay. Alright. So yeah, and here the last one is outline or center line should not be used as a dimension line. Should not be used as a dimension line. For example, here, if I take this example, let's say this is the center line. Alright, then this is the outline. So we cannot give the dimension like this. We cannot give the dimension like this. Alright, we cannot use the center line or outline as a dimension line. However, we can extend the center line. For example, in that case, what we do, we extend the center line here and from this to here, then we can give this one. Alright, okay, give this one. Otherwise, should not use the outline or center line. Alright, for example, let's say in the second case here, let's say this one. If I am taking this, let's say 30. So as far as possible, you should avoid these things. You should not give the dimensions inside the drawing. So this is wrong. So better what you do this, extend, and you place the dimension here. Alright. So this is correct, this is wrong. Alright. So these are the minor things you should follow in the drawing. Okay. So any doubts or any queries about the dimensioning? Any doubts or any queries about the dimensioning? Okay, so I think we have cleared a lot of things. And the last thing is about the scaling. We'll talk about the scaling. So why the scaling is required? Or what do you mean by scaling? Now, if you consider the example of building, how you can draw the outline or the different views of the building on a small piece of paper. This is possible through scaling. This is possible through scaling. Even let's say for example how the microscopic objects, how the microscopic things can be put on the bigger paper. This is also possible through scaling. Alright. So here what we do, sometimes we use the reduced scale. Sometimes we enlarge the scale. Alright. In some cases we can use the scale as it is. Alright. The scaling is defined as it is the ratio of the dimensions of the element represented on the drawing to the actual dimension of the element. Okay. So it is dimension on the drawing of the element divided by actual dimension of that same element. This is the scaling. Okay. And suppose if you are drawing with the scale, same scale, the drawing is prepared with the actual scale of the object, then we can call this as a full size scale. Full size scale. Alright. And the corresponding drawing is called as full scale drawing. Full scale drawing. Alright. For example, how we can put the bigger building, bigger pictures of the building or views of the building on small piece. This is possible through reduced scale, where what we're doing, we are drawing the object smaller than the actual object size. Alright. So here we can call this as a reduced scale. Reduced scale. So here how the reduced scale is represented: 1:2, 1:5, 1:500, 1:1000, 10,000. So that means the first part is the dimension on the paper. Dimension on the paper. The second part is the actual dimension. Alright. Actual dimension. For example, 1 mm on the paper is equivalent to, let's say, 2 meter of the actual dimension. 2 meter of the actual dimension. Or 1 meter or 1 mm on the paper is equal to 4 kilometer of the distance. Alright. So we are reducing 2 meter to 1 mm, 4 kilometer to 1 mm. Alright, so we are reducing the dimension. So that is called as reduced scale, and the corresponding drawing is called as reduced scale drawing. Reduced scale drawing. Similarly, we can enlarge the drawing. Enlarge the drawing. Alright, so we prepare the drawing larger than the actual size, are called as enlarged scale. And how enlarged scale is reported? 50:1. For example, microscopic things. Alright. So 50 mm, for example, this 50 mm, this is 50 mm is on the drawing sheet. 50 mm is equal to, let's say, 1 mm or say 1 micron. It's like this. Okay. Or say 10 centimeter on the sheet is equivalent to 1 millimeter or 1 micron. Alright. So in that way. Okay. So this is the enlarged scale. Alright. So why it is necessary? Because we have limitations, right? Because we have seen the sizes of the drawing sheets: A0, A1, A2, A3, and so on. Alright. So how we can properly utilize that drawing? So through this full scale, reduced scale, and enlarged scale. Alright. So whenever we use either reduced scale or enlarged scale, we must mention it on this drawing. We must mention it on the drawing. Now let us go back to the here. Alright. On the drawing sheet, what you do, you mention the scale somewhere over here. You write the scale and you write, suppose if you are using the other scale than full size scale, then you can mention, let's say 1:5. All right, 1:5 in case of reduced scale. In case of enlarged scale, you can also write the other way, 1:, let's say 0.01. This is the enlarged scale. All right, so either you mention this thing depending on the which things you are used. All right, so even in some cases, let's say the drawing is too big, then you can use this things. Okay. All right, so you mention the scale just close to this title block, somewhere like this one. All right, you mention like this one. All right. Or even in some cases you can also draw it somewhere over here. Okay, so we can make an additional row here. You mention the scale. All right, in case we are using the enlarged scale or reduced scale. Okay. All right, so this
Sir,
information, yes.
in
So what does this
enlarged
1:2 mean? In the sense, what is the scale and what is the actual?
Sorry, what?
So in this ratio, you were writing 1:2.
Yes,
What is the full statement for it?
1:2. Okay, preferably in the drawing we are referring, for example, I'm giving, I think we have the examples. Yeah, 1:2. This is just an example. All right, so what it means, the one is referring to the 1 mm, let's say, if we are using the millimeter scale on our drawing. All right, and this is the preferred. If you look at the drawing sheets, the millimeter scale is commonly adopted on the drawing sheet. Okay, so this 1 mm is corresponding to the 2 units. All right, 2 units. So this can be anything depending on what we are doing. Whether we are drawing the objects which are too big, which are preferred in the centimeter, then we can give the centimeter. All right, if we are drawing the buildings, huge structures, then 1 mm is equal to 2 meter. All right, and in some cases we can also give 1 mm is equal to 2 mm if the drawing or the object is just big enough, just bigger than our drawing sheet. All right, then we can use 1 mm is equal to 2 mm, means 2 mm is the actual size of the object, actual size of the object. Okay, and this 1 mm, this one is the dimension on the drawing, dimension on the drawing.
Thank you. Thank
Okay, yeah. All right, now
instead of writing in
engineering,
ratios like 1 mm equals to 2 kilometer or 2 meter.
uh, no, actually, that we are discussing here, engineering scale and graphical scale. Okay, that we are representing it through the representative function. We are going to that. We are going to that. Okay, now,
Sir,
yes,
sir, in a large scale, it is just opposite to reduced scale.
yes,
Sir, so we can say if the actual size of the object is 1 mm, then it must be in drawing, then it can be 50 meter.
50 meter. Actually, what we are doing, we are referring this 50. So these are just an example. 50:1 means 50 mm on the sheet. All right, so we can write in other way, 1 mm. So this becomes, we divide it by 50. So 1 by 50. All right, let's say this 50 mm is equal to, let's say, 1 meter. So what will happen? 1 mm on the drawing sheet will be equal to 1 by 50th meter, the actual scale. Okay, so
Yes.
we have here the examples. We have here examples. It will get clear. Okay, don't worry. So these are called as engineering scale. What do you mean by engineering scale? Engineering scale, as we are engineer, we are mentioning the scale on the drawing. We are mentioning the scales are drawing numerically. This is important thing. This is important thing. We are mentioning the scale or the relation between the actual dimension and the drawing dimension is the numerically on the sheet. Like for example, 1 mm is to 1 mm. That is the full scale. Let's say 1 mm is equal to 5 meter reduced scale. We can mention it on the sheet. All right. In that case, when we have the different units, then we must mention it with the units. We must mention it with the units. All right. So in that some case, what we can also write 1 mm is equivalent to, we can convert this into. All right. So in that case, how we can write? We can write simply 1 as 2. Now here we can write in this way when we have the units are same. mm. If we have the different units, then you can write in terms of units. 1 mm is equal to 5 meter. Okay. All right. So either we can mention in this way or we mention in this way. Okay. All right. So we can mention in this way or we can mention in this way. All right. So in practice, this method is preferred. In practice, this method preferred. We do not put any unit here. We do not put any unit here. Okay, we represent this as a fraction, a representative fraction. Representative fraction. All right. Also in case of the enlarged scale, let's say 1 mm is equal to 0. So this can be referred as 0.01. 0.01. All right. So we can put this simply on the drawing. Okay, so what we do, we write scale 1 as to 0.01. That means, and if we are mentioning the one note, all dimensions are in mm, then that means 1 mm on the drawing sheet is equivalent to 0.01 mm of the actual size. Okay. All right. Also, another example of enlarged scale, let's say 1 mm on the drawing is equal to 1 micron. 1 micron. All right. So either you can mention 1 mm is equal to 1 micron on the drawing, or you can also mention 1 is to how much, then it will be 1, right? In this way, 0.00001. All right. So this is the enlarged scale. All right. Now this is the, we are just mentioning numerically. So that is why it is called as engineering scale. Engineering scale. Now, what will happen if we keep the drawing for the years? All right. So due to the property of the drawing paper, all right. See, the drawing paper shrinks. Drawing paper shrinks. All right. When the drawing becomes old, the engineering scale will shrink. All right. And in that case, when we try to obtain the readings on the drawing, then we get the inaccurate results because of the shrinking of the paper, shrinking of the drawing. All right. So for these, in order to overcome this issue, we use the graphical scale. What is graphical scale? So here what we do, we draw the scale itself on the drawing paper. We draw the scale itself on the drawing paper. All right. So if we go to the drawing paper, what we do here, as a some reference, we draw the scale. Let's say this. okay, or maybe just a single line, just a single line. Okay, so here 1 2 3 4, okay, so 0 1 2, we draw this actual scale, on the drawing sheet. All right, so in that case what will happen, even if the drawing paper shrinks, the scale will also shrink. All right, so the ratio between the actual dimension and the dimension of this drawing, that will be remains constant, right? The ratio will be remain constant. All right, so that is the advantage of using the graphical scale. All right, however, these graphical scales, these are used in case of the survey maps, which are required to preserve very long time. All right, however, for our most of the cases, what are the commercial drawings are all mentioned the engineering drawing, engineering scale, or engineering scale. All right, so we just mention on the paper numerically like this: 1:2, 1:10, okay, or 1:0.01, like this. We do not draw any scale on the paper. Okay, so this is the difference between the engineering scale and graphical scale. All right, and the last factor, this is the representative fraction. All right, so this is the scale only, right? The length of an element in the drawing divided by actual length of the element. All right, so we represent this as a fraction. For example, 1 mm long line in the drawing represents 1 meter length of object. All right. However, this RF is always represented in the same unit, as we are representing as a fraction. It's always referred in a same unit. All right, so we convert this into 1 mm divided by 1000 mm. All right, so we remove this one, so representative factor will be 1:1000. 1:1000. Okay. All right, so in our case it is hardly required to use it. All right, it is hardly required to use. All right. So our scaling is preferably in the mm itself, 1:5 mm, 1:2 mm. All right. So maybe in some cases 1:0.2 mm, 1:0.5 mm, or 0.1 mm. So, all right. So these scalings are required when we have the complex objects, when we have the very small objects, micro scale, or when we have the very large objects, buildings or infrastructures. All right. So we are not going into that much detail. Okay. All right. Okay. So this is all about the basics. Okay. So any doubts or any queries here?
Sir, sir, can't we write 1:0.01 as 100:1?
100:1. Yes, you can write. Actually, but what we're doing, for ready to pick the dimension from the drawing, it is preferable to give the one as to something, 1:something. All right, because then we can easily measure. We put the scale on the drawing paper. We count whether it is 10 mm, 5 mm, 7 mm, 20 mm. Then we directly convert it. All right. If we use, like you said, 100 mm on the drawing is equivalent to let's say 1 mm in actual size. All right. Then again we need to convert it, because this 100 mm is on the drawing. All right. So rather we represent it like this. Okay, 1:0.01 meter mm. Okay, or 1 millimeter is equal to 1 micron. 100 micron, 50 micron, so okay.
Yes, sir.
Yeah. All right, so this is all about the basic part. All right. Now here I will provide you the drawing sheet number 1. Okay, later. So in that, I think you have some question on the lettering. Okay, so you practice this later somewhere. Okay, so a sentence will be given to you. So you write the sentence in the capital letters or in the combination of the sentence case letters. All right. So
Sir,
you follow this. Yes.
sir, the line above the bar line, what is the name for it?
Line about this one. This one ascender.
Sir, below it.
This one descender. Ascender, descender. Okay. All right.
Sir, are both the middle line called bar line?
Bar line. You can bar line, not bar line. Where is bar line? See here what we have. We have the topmost line, this ascender. The bottommost, this is the descender, and where the letters sit A, B, E, they are all sitting on the one line that is called as baseline. That is called as baseline. Okay.
Sir, the line above the baseline, what is the name for it?
This line.
Yes, sir.
This line, I think for this one we do not have any name particularly because this is based on the body height. This is based on the body height. All right. So there is no particular line name for this line. Okay. Based on the body height, this line changes. Okay. In some cases, it is required. Let's say 9 mm, or let's say 5 mm. So this will vary. So there is no particular name for it. All right. So this is variable. Okay. The only the ascend, even in that case, the details about the ascender, descender, and all this is not required at all. All right. The only thing you need to follow this: the all the letters should sit on the baseline. Okay, they should on the baseline. All right, and this height measured from the baseline to the capital letters. This is the cap height. All right, and the body height. Body height here. How the body height came into the picture? From the letters like A, E, right, or O, X. All right, so they are fall under this one fixed height, that is the body height. That is the body height. All right. And this height, the ascender or descender, this height is optional. This optional. All right. So this you can adapt yourself. Okay. So this is no hard and fast rule yet. You must use that in proportion. Okay. So if the body height is say 8 mm, then it should be 8 mm or 7 mm or 6. It is not like that. You can use it anything as long as we can see the letter the attractively, all right, or the decently. All right, so it should not be too big, it should not be like this, all right, or it should not be too small, or it should be appropriate. All right, so this is based on the scale. This is based on the scale. All right. Okay. Right, so this is all about the first one. Now, as a part of this, we need to recall some geometrical construction. We need to recall some geometrical construction. All right, and I think you might aware of the you might learn the geometry in your during your high schools, right? How to bisect the line, how to bisect the arc. Anyone know the procedure?
Yes, sir.
Right? So this is very simple, right? How to bisect the given line and how to bisect the arc. Right? So
Yes.
this process you must recall. This process you must recall. Right? Also, the construction of triangle square. Also, these are simple. We can do it. However, when we go for the construction of a regular polygon or any polygon, what do you mean by a, have you heard the word regular polygon?
Yes, sir. The figure
What do you
is
mean
the
by
same.
regular polygon?
Yes, sir.
What is regular polygon?
All the sides are equal.
Equal.
All
Yes.
right,
Equilateral triangle.
right. All right. So that is correct. So here we are focusing on the drawing of regular polygons. All right. In most of the cases, we are using the geometries are like that. They are regular. They are regular. All right. Now let us discuss one general method used for drawing the regular polygon. Regular polygon. All right. And also the methods may be covered in your high schools as well. Okay. However, just as a part, we need to discuss one common method. One common method. All right. Now, what we do, let us see the general procedure, because this common method, this general method, we can use it for square, regular, pentagon, hexagon, heptagon, octagon. All right. So for n number of sides, we can use this method. All right. So that is why it is called a general method or common method for drawing the any polygon. All right. Now let us see. There is a few initial steps are common for all. Now let's see what we do. First of all, let us imagine we have to draw a polygon of any given length. Okay, let us assume first 50 mm. Okay, just an example. Okay, so this line is given. Okay, so example will be like that. Construct a regular heptagon of side 50 mm. Alright. So the first task is draw a line AB, or you can give any name, okay, of given length like this. Okay, draw a line AB like this of the given dimension. The next task, now we start the construction. This line AB is one of the sides of the polygon. All right, and whatever we are doing, the remaining constructions, these are all the construction part. All right, so that is why we are representing the line AB using thick line, and line BC, that is the construction line, we are representing using the thin line. Okay, so the line BC is visible to you all,
Yes, sir.
right?
Yes, sir.
It is thin line, right? So we can easily differentiate between the thick line and thin line. All right. So whatever the construction part is there, we must draw in the thin line. Okay, so the next step is what we do here. We draw line BC perpendicular to AB. All right, and here this line BC is equal to AB, which is perpendicular and equal to AB. So this is the next step. Then what is the next step? We join the line AC. We join the line AC. Again, AC is the thin line. AC is the thin line. The next step what we do, we use this B as a center and AB as a radius. We construct this arc AC. We draw this arc AC. B as center, A as, and AB as radius. We construct this arc. Alright. Now what is the next step? Next step, we bisect the line AB. So we draw perpendicular bisector of line AB. Alright. So whatever the line is indicated here, this is extended. So this is perpendicular bisector. So this is equal. This is equal. So we draw perpendicular bisector of line AB that intersects AC at 4 and arc AC at 6. So we are getting two cutting points, and we are giving the particular numbers 4 and 6. Why 4 and why 6? It will be clear. So there is a specific meaning why we are giving the number 4 and number 6. Okay, so it will get clear. Alright, so this is the basic construction. Alright, so I will explain why 4 and 6 later. Okay, now with this, let us try to construct the square. Okay, so this is common. All the steps we have discussed, this is common for all the polygons. Now from this onward, we modify this construction, or we update this construction depending on our requirement, which polygon we are going to draw, whether it is square, pentagon, hexagon, heptagon, so on. Okay, so let us discuss few examples. So let us first try to construct the square based on the previous construction. Okay, so here we try to construct with that. So what we do, as we already know, we have the basic construction ready, right? AB 0.4 and 0.6. Alright, now what we do here, we construct one circle. We draw one circle with center 4 and radius A4. Okay, center 4 and radius A4. We construct the circle. Alright, do note that this circle inscribes the square. Okay, or we can say the square to be drawn is inscribed in that circle. Alright. So once we have this circle drawn, the next part is easy. Alright. As we are going to construct the square, what we do, we already know that the length AB. Alright, we just take this in the compass, right? We put mark here, right? Keeping one point here, we mark here. Keeping one point here, we mark here. Alright, and you simply join these lines. Right? We simply join this. Or what we do, we simply draw one perpendicular to AB from B, like here. From here to here, we can go up like this. And from here, we also draw one line. This is perpendicular to AB. Alright, and you simply join this. So the ABC can give name. Alright, so this is very simple. Since this is square, this is simple. Alright, now in this way we can complete this square. Alright, now let us talk about, now you might have guessed what is the use of this 4 now, right? What this 4 refer. So using the 4 as a center, we have constructed the circle where we can get the inscribed square. Right? where the square is inscribed. Alright. Now this 6, what do you mean by this 6? Let us understand. Let us try to construct regular hexagon. Regular hexagon. Alright. Now again we follow the first few steps common. Alright. And now what we do? Now we use 6 as a center. 6 as a center, and radius is equal to A6. Center 6, radius A6. Right? Center 6, radius A6. We construct one more, or we draw one more circle. Alright. So with this, we can obtain the regular hexagon inscribed in the circle. Inscribed in the circle. Alright. So here, the 6 is referring to the. This is to be used for constructing the hexagon. Alright. So once we draw the circle, what is the next step? We take the distance AB in the compass and keep on marking here, 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 and here. Alright. Okay. And then what is the simple next step? We simply join these lines. Right? We simply join these lines.
Sir, can you explain how did we get 6?
How did we get 6?
Yes, sir.
Okay. So did you get the first part?
Sir, I got the first part. I didn't get how we got 6.
Yeah. Okay. So this is the first part we had, right? The initial line AB, then we have constructed this line BC perpendicular, right? Perpendicular to AB. Then we have joined this line AC. Later part, what we have done, we have constructed an arc AC with the center B. Center B, radius equal to AB. We have constructed this arc AC. Then in this part, what we have done, we have drawn perpendicular bisector of AB.
Yes, sir.
Right? Perpendicular bisector of AB. Now this perpendicular bisector intersect line AC at 4 and arc AC at 6. Right?
Okay.
So these are intersecting points of the perpendicular bisector.
Okay.
Got it?
Yes.
All right. Now, and as we've seen, the 4 to be used for construction of the square, 6 means to be used for construction of hexagon. All right. Now since we know all those things, for construction of regular hexagon, what we do? We use the center 6 and radius is A6. All right. And we simply draw one circle. All right. And what we do? We take the distance AB in the compass and go on marking on the circumference. Okay, go on cutting this and simply join all those things. All right. And later you can also give the names A, B. C is already given, so you can give the names. Okay. All right. So this is the construction of regular hexagon. Now,
Sir, how did we
Now-
mark these points? Like, I think first from the A and then C and then this type, sir.
yes, yes. What we do? First of all, take the distance AB in the compass. Okay, one key point, one point at the B, other point with the pencil we mark here. Right? Then once we got this point, let's say D, we keep one point here with the other point in the pencil we mark here. Right? Similarly, we are shifting the point of the compass from point to point. Right? So this is simple.
Yes.
Got it?
Sir,
Here we have to
why
make use of compass. Ah, yes.
why is 6 the center of this hexagon? Like how mathematically, how do we arrive at the fact that 6 should
So
be the
this is
center?
this is all based on the geometrical construction. So I do not know how the theory is behind it, but uh, they might have done some extensive work behind it. So they have come up with this approach. All right.
Okay, sir.
Okay. So this is just in one method. So you can find many other methods. You can find many other methods. All right. So this is the common method or general method of construction. Okay. All right. Now with this, we have obtained the square and hexagon. Now what about the other? Let's say how we can obtain the pentagon. So for pentagon, what we do? We need 0.5. So where do you expect the 0.5 will be?
Bisector of 4.
Midpoint of 4.
Yeah. So
Mid-weirdness.
what we do, let us take an example of construction of pentagon. All right. So what do? We mark the midpoint of line 46. Okay. Mark midpoint 5 of the line 46. All right. So what we do, we simply measure the 46 and you simply mark the midpoint of this line segment 46. All right. And this will give you the 5. This will give you the 5. Similarly, if we want to construct the next heptagon, then what we do? We take the distance 4, 5 in the compass, then mark here. Again 7. Then take the same distance 4, 5 in the compass, mark here. We'll get 0.8. All right. So in this way we can go on construct. Okay. And for constructing the respective polygon, what do? We use, let's say for example for pentagon we use 5 as a center and this has a radius. This has a radius. For heptagon, what we do? I will just write. For pentagon, what we use? Center, and for pentagon 5 and radius is a5. Right? For let's say octagon. Octagon, what we use? We use 8 as a center and radius is 8 or a8. All right. So in this way we can. All right. Now let us discuss this part. Let us discuss this part for the construction of pentagon. Okay. Same thing. For this one, what we do? With the center 5 and radius is a5, we draw the circle so that we can inscribe the pentagon here. Okay. Center 5, radius a5, construct the circle, take the distance AB in the compass, put one point here, and with the other point holding pencil mark here. Right. Then next, after getting this point, put one end here with the other end holding pencil mark here. All right. Similarly mark here. All right. So this is very simple. Okay. Then we'll get the 5 sides. Okay. So this is very simple construction. Okay. So you can practice all those things. You can practice all those. Okay. So any doubts or any queries here? Any doubts or any queries?
No, sir.
No, sir.
Sir,
No, sir.
Sir,
Okay.
why are we constructing the regular polygons via the center? Because we can construct the regular polygons without using the center also by a protected compass.
Yes, we can construct it. Like we can directly construct. How we can directly construct? This is a general method because we need to know these things. All right.
We can
Otherwise,
directly by the protector.
yes,
By the protector, we will. Yes, sir.
why this is required? Because at least we need to know how we can use the instruments properly. All right. Because otherwise you can directly construct. How we can construct? We simply draw one line AB. Then what is the interior angle? What is the interior angle here, 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 here? Anyone knows?
72 degree.
In the pentagon,
Yeah,
72 degree.
72 degree.
108 degree.
Interior angle 108 degree. Right? And how to compute that? Anyone know the general formula for this one? For any regular
We can
polygon
do
of
Yes, sir. N minus 2 into 180 by n.
okay, and what is n?
Number of
Number
sides.
of sides.
Yeah, let's say
N
this
is the
theta is the interior angle. I will write n minus 2 into 180 divided by n. All right. So this n being the number of sides of polygon, right? So this is just the element. So these methods are just for the information because you need to know how these the
I use
constructs
mute your
are
mic.
being made, right? All right.
Yes, sir.
Yeah. Okay. So any doubts or any other queries in this method? I think this is very simple method.
Yes, sir.
Okay. Now let us say there is one question like this. For the same side, for the same common side, you need to draw a square and a say regular pentagon bearing a common side of 40 mm. Okay, a square and a regular pentagon. All right. So here we can have these two solutions. These two solutions. Okay. So which one is correct?
Both are correct.
A is correct, sir.
Sir, both are correct.
Both are correct.
Yeah, both are correct. Both are correct. All right, because we are satisfying. We have to construct the square and regular pentagon of common side. All right, so here this AB is being the common side. All right. So either you can construct in this way or the other way. Both are correct. Both are correct. Okay, so this is just an illustration. This is just an illustration. So you can construct the multiple polygons. Okay, so even you can construct the hexagon, right? So you can construct the hexagon over here like this. Okay, even you can construct the heptagon, octagon on the same base, or the common side. All right. So this is just an example. Okay. All right. So I think with this we can stop here. Okay. So all the sufficient information has been given for your sheet number 1. Okay. So any doubts or any queries?
Sir,
Yes.
sir, I have to know about once again about the center line.
Center line. Okay. line. This one. This one.
No, sir, the variation of lines part.
Oh, variation line for okay. I thought variation of center line construction. Yeah. For the center line, it is usually used for the objects like circular hole or circle. Alright. So for example, how it is represented, we will show you here. Okay. So let's say the circle. Alright. So the center line is represented. Whenever we have the circle, we need to represent the center of that circle. We need to represent the center of the circle. So what we do, we draw this line. Alright. So the intersecting point of these two center lines is nothing but the center of that particular circle. Alright. So for circular object, we need to show this one. We need to show this one. Okay. And here the circle line, the center lines are denoted like this: long dash dot, long dash dot. Okay. So these are all given. Yeah, these are all given over here. Okay. Also,
Sir, can you again?
you refer the notebook that I will provide. Not notebook, sorry, I will provide you the one reference book, engineering drawing. Okay. So in that you can also refer the various types of lines and their applications. Okay. I will provide you the slides, the notes, and the one reference book.
Okay, sir.
Okay.
Sir,
Yes.
can you please explain for the sheet one what will we have to do in that?
Yes. I will provide you the sheet. Okay. So I have
Sir, sheet
created. You
one.
might have
It will
received.
be in assignment section.
Sorry, what?
Sir, will it be in assignments?
Yes, in assignment. That is I'm talking about. So you might have received one another invitation to join the Google Classroom, right? Have you received?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
All right.
Yes, sir.
So for
Yes, sir.
this Google Classroom is especially for submitting the assignments. Okay. So you draw the sheet, you complete the sheet, and you submit in the Google Classroom, not on the Teams.
Sir,
In
it
the
is
PDF format.
all the teams. It is for all the
Yes. You submit the sheet in the PDF format. Okay.
yes, sir.
Submit the
Okay,
sheet
sir.
in PDF format. And in case if we are having the more than two sheets, three sheets for a single assignment, then you combine all the sheet in a single PDF only. Okay.
Okay, sir.
Yeah. Only upload only single PDF. Okay. Do not upload the multiple PDFs or multiple sheets. Okay. You combine all the sheets in a single PDF in a sequential manner. If you have, let's say, the 4 examples, and uh, each example requires one sheet, then you will be having the 4 sheets. Okay. So you combine all 4 sheets sequentially for problem number 1, problem number 2, and so on. Okay. Then you combine and you upload only single PDF. All right. So I will provide you the assignment. I will upload it today, and do note that there is a submission deadline for each assignment. There is a 1 week time. All right. And as we already discussed, there's a 40% weightage for the sheet. So timely submission of sheets is expected.
So
So
what
we
have
have
you
to.
written besides 40%? 10 what? 10 slots or what?
No, there will be 10 sheets.
Okay,
There will
10
be
seats.
10 sheets, carries 10 mark each.
In all over the first semester.
Yes. So weekly you will get one sheet.
So we have to do in A3 sheets.
A3 sheet. Yes. I already told, right? So
Yes.
you take this one. You purchase notebook of A3, or you also purchase the A3 loose sheets as well. Alright, and you prepare the layout title block like this. Alright, name, roll number, started on, finished on, everything here.
Okay. There is not a particular dimension for the title block, huh?
There is no particular dimension for this because depending on the length of your name,
Yes.
though you can maybe you can fix the size of the letter. Okay, this is even your choice. Okay, so just make it visible. Just make it visible. So everyone can easily read what is written. Okay. Yes.
Sir, if we are having multiple pages in a PDF, then do we have to make title block in every page or like on the front page only?
I think you make it on every page.
Okay, sir.
Okay, you make it on every page.
So then we should draw in the remaining area.
Yes, you draw in the remaining area. Do not make the title block too big.
Okay.
Okay, don't make it too. And even you can use the other side as well, no problem. Okay, so because the drawing sheets are thick enough. Alright, so they are thick enough, so you can draw on both sides. Okay. Usually the drawing sheets are thick enough, so you can draw on the both sides.
So we should.
Please turn off the microphone. Yeah.
So we should make title block on the other side as well, or only on the single side?
Title block maybe on the single side, that is enough.
Oh.
However, or in some case, maybe in case of single PDF, you can make only single block. That is also okay.
Okay.
Okay. Because in some cases, what will happen? You have to attach the, let's say, 4-5 sheets. Okay. So just for convenience, you put the title block on a single sheet. That is fine. Now,
Okay.
since it is the online mode, so this is allowed. Always. Otherwise, when we submit it in the hard copy, the offline, we have to make it on the every sheet. Okay. So if time permits, I suggest you prepare the title block, draw the title block on each and every sheet. Okay.
Okay, sir.
Yes. So in title block also we should make 4 lines and then write.
No need 4 lines. This is, I suggest you for the in the title block you use the capital letters all. Okay, so you will have only 2 lines. Okay.
So
Yeah, and however the lines you can make it very thin, as already suggested. Okay. All right. Okay. So any other doubts? Any other queries? Okay, so maybe we stop here. Okay, and what we do, I will provide you the note